Hey, I'm Mr. B, and today we are solving systems of equations, but we're doing it with the substitution method. Now, just so we know what we're talking about, here I just have two lines, and here I just have two lines. How do I know they're lines? Because I don't see any x squared, any y squares, any x cubes, nothing like that is flying around. So I know that this is just a line, and this is just a line. And my goal is to find the point where those two lines cross. I already did it graphically. You should watch that video to understand what's going on. But now I'm going to do it without graphing, which is kind of cool. But it depends how the equations are given to you. How the equations are given to you best determines which method you should use. So here, the equations are given to me in a way where y is by itself. Y is by itself. Because the variable is by itself, it's easy to substitute with, and I'll show you that, I'll demonstrate that in a second. But I know to substitute because the y or the x is by itself. This one here is going to be something different. This is eliminating. How do I know to eliminate? If I look here, 3x plus 4y equals 50, that doesn't tell me what x is. X is not by itself, y is not by itself. And this bottom one, no help either. 6x is not by itself, and the negative 10y, they're not isolated. I could do the math to isolate them, but I don't want to. I could use the elimination method to solve that, which is going to be a second video. Today's video is going to be how to substitute. But you have to know when to use each, and I want to use substituting when it gives me y equals or x equals. So let's jump into my first example. I know y equals 2x minus 6 and y equals 4x plus 12. Remember, these are just two lines. I want to find the x and the y where these two cross. With substituting, what does that mean? It means I'm plugging something in for something else. It tells me that y is equal to this. Okay, and if y is this, then this is a y, which means this is this. I'm going to say it again because I know that was confusing. Y is this. Cool. Just like if y is 5. If I told you y is 5, you would plug in a 5 here. If I told you y is 10, you plug in a 10 here. However, it's a little more complicated. I'm telling you y is this. But it's the same exact thing. I can replace this y with this. Right? All I did was just physically erase that y and put what y was equal to. And why is that helpful? Well, now I have an equation with just x's. How do I solve this equation with just x's? I got to move things around. I have a 2x here. I got to subtract 2x, subtract 2x. I'm left with negative 6 equals 2x plus 12. I moved that 2x over by subtracting 2x. And now I have x's over here. I have just one x term on one side. Now I gotta get that one x term by itself. There's a minus 12 next to it. Sorry, plus 12. So I minus 12 to get rid of it. If I do it to one side, I do it to the other. And I get negative 18 equals 2x. Is my x by itself? No. There's a 2 next to it. Divide by 2, divide by 2. X equals negative 9. Just to recap, I did that a tiny bit fast. I substituted this, 2x minus 6, into the y spot. I then just had to solve the algebra of getting the x by itself. There were x's on both sides, so I moved one of the x's over. I chose to move the smaller one over. That way I don't have to deal with negatives. If possible, choose the smaller one. What do I mean by smaller one? 2x is less than 4x. So I move over the 2. I subtract 2x. If I do it from one side, I do it to the other. Notice how I subtracted the 2x from the 4x spot. I don't do it with the 12 because 12 and negative 2x can't combine, but 4x minus 2x can. 4x minus 2x, that is just 2x because 4 minus 2 is 2. And now I have to get this one lone x by itself. There's a plus 12 next to it, I minus 12. If I do that to one side, I also do it to the other. Negative 6 minus 12 is negative 18. Negative 18 equals 2x. X is almost by itself. Divide by 2, divide by 2. X equals negative 9. Once I have x is negative 9, I'm not done. I also have to find x's best friend, the y. How do I find the y? Is I take this x and I plug it back in to the x from either original equation. It doesn't matter which one. I'm going to do this top one. 2x minus 6. Well, y equals 2x minus 6. Let me do it over here so I can see better. Y equals 2x minus 6. This x is just a placeholder. I don't know what it is, but I actually do know what it is now. So now, since I know it's negative 9, I can replace that x with negative 9. And 2 times negative 9, that's negative 18. And then it's y equals negative 18 minus 6, which is negative 24. Which means my answer is negative 9, negative 24. That is the coordinate where these two lines would cross. Cool. I got another one in case that one didn't fully make sense. Same kind of idea here. Y is this. And since y is this, I can replace this y with this. That's the substituting part. I took this and put it there where the y was. Now I just solve this for x. I have x's on both sides. I have to move one of them over. To move over a minus 3x, I'm going to add 3x. If I add 3x to one side, I do it to the other side. And I notice how I add it with the other x term. 5x plus 3x is 8x. I'm left with 4 equals 8x minus 44. To solve this, I need this x by itself. I add 44. I add 44. I get 48 equals 8x. The x is not by itself. There's an 8 in front of it. Divide 8. Divide 8. X equals 6. Let me write that a little better. X equals 6. Cool. Just solve for x. Once I have x, I have to find x's best friend, the y. To find y, I take this x, and I can plug it into either equation I like. I did the top one last time. I'll do the bottom one here. It does not matter which one. Whichever one looks nicer to you. This bottom equation was y equal 5x minus 44. X is 6. So instead of x, I can physically put 6. 5 times 6, that's just 30. 30 minus 44 is negative 14. Which means on a graph, these two lines would cross at the coordinate 6, negative 14. Cool. One last one. This one is a trickier one because this top one is 3x plus 2y equals 11. It doesn't give me what x or y by itself, but the bottom one does. It tells me x is this. And if it tells me x is that, I can put this in place of that x. So my original equation is 3x plus 2y is 11. But now I'm going to almost erase that x and put y plus 12 in its place. And the benefit of doing that is now I have an equation with only y's. I still have math to do. There's a 3 outside of this parentheses, so I have to distribute it. And I get 3y plus 36 plus 2y equals 11. To get, I have 3y and 2y. Those combined become 5y plus 36 equals 11. I'm going to zoom this out, move it up a tiny bit. I'm not going up actually. How do I get y by itself? Minus 36, minus 36. I'm left with 5y equals 11 minus 36 is negative 25. Divide by 5, divide by 5. Y equals negative 5. Does it matter that I got the y first? No, but I still need to find the x. Once I have this y, I plug it in to that equation. X equals y plus 12. I now know y is negative 5. X equals negative 5 plus 12. Because instead of y, I put negative 5. Negative 5 plus 12, that's just 7. So my final answer is 7, negative 5. that is where these two lines would cross. Hope that made sense. That's a substitution method.